Good job. All right, this is 1.7 function notation. Okay. There's two things that I want to talk about in this section, but I only have time to talk about the first, which was my plan anyway. So we're talking about 1.7. We need to understand function notation. Function notation looks like this. Instead of what we just got done talking about, y equals 3x plus 2, it now says f of x equals 3x plus 2. That's how you read that. Everybody say it. F of x. Say it again. F of x. Let me say it and then you say it. F of x.
F of x.
There you go. F of x is how we read this. It is the same as y. Okay, they're interchangeable. We'll do more of that later. But right now, for these problems in your homework, I want you to be able to do problems that look like this. F of 2, that's how you read that. F of 0, and F of positive 2. Okay? This is function notation. We are just like we did talk about the other day when we had the function box. We are putting in an x. It is going into the function. We now have a definition for that function. In this particular case, it's 3x plus 2. We put the x in, the x is negative 2. We turn the crank, right? And what comes out? What is our output? The y. Okay, you're right. You're right. The y is the output, or the f of x. Right? F of x and y, they're the same thing. So we're going to put in negative 2, and our outcome is the output, the y. Right? How does that work? Let me erase that. Well, f of negative 2. Whatever's inside this parentheses simply goes right there. It gets replaced for x. Right? F of x, there's x. Instead of x, I'm saying negative 2. So that negative 2 has to go in for x. Okay? I put it in there, I turn the crank, meaning 3 times negative 2 plus 2. And what do I get? Do that in your head. What do you get? You get negative 6 plus 2, which is negative 4. Don't forget about the plus 2. Right? We turn the whole crank. I'll write it like this. Let's see it like this. 3 times negative 2 plus 2, which equals negative 4. I'm taking that negative 2 and I'm plugging it into the function. Okay? Same thing with 0. What do I do here? Take that 0 and do what with it? Plug it in. So that would be 3 times 0 plus 2. What would the answer be? Positive 2. Okay? Positive 2. F of 0 equals positive 2. All right, how about this one? F of 2. What would that one equal? Positive 8. Get the hang. If I wanted to write a very simple T-chart that corresponded to this, what would my domain be? What 3 values are my domain? Negative 2, 0, and 2. What would my output be? Could you graph using those 3 points? Sure you could. Sure you could. Okay. Questions? Let's do another example. Another example. Let me erase this and this. So the function is going to change. Okay, and I'm going to say negative 1/4 x plus 2. And I want to know what f of 1 would equal, f of 0, and f of 4. Okay, now we've got a fraction to deal with. It's not quite so easy. But we can use our calculator. Go get your calculator out. When I do f of 1 and I plug in 1, remember that 1 is going right there for x. Right? Type it in on your calculator and see if you can figure out what it's going to be. Okay? Some of you can do it. I would use the fraction button and I would say negative 1/4 times 1 plus 2. Type that in on your calculator and tell me what you get. Positive 7 over 4, is that right? Yeah, so fractions, you should not be scared of fractions. You shouldn't see a problem and see that negative 1/4 and say, oh, I don't know what to do, I don't know what to do. Okay, function notation. How about f of 0? Do you need your calculator for that? No, that's the easiest one to plug in. Why? When I put 0 right there, all of that just goes away. Okay, so f of 0 is equal to what? Positive 2. Anybody not understand where I'm getting these numbers? Raise your hand. Anybody not understand where 7 over 4 or 2 came from? Right, good. How about the last one? F of 4. What's that going to equal? Well, 4 right here would cancel out with this 4. That's nice. And so I'd have negative 1 plus 2, and that means it would be 1. All right, questions? Any questions? Any questions? All right, who thinks that I can't stump with a problem like this? All right, you ready? All right, everybody write this down. You just did these 3 problems, but if I give you f of a, that hangs people up. They don't know what to do. If you get this right, I'm going to be impressed. What do you think? What is f of a equal? On the right track. Oh, you're so close. So close. All right, I'll give you a hint. When we did f of 1, we took that 1 and we substituted it in right there. When we did f of 0, we took 0 and we substituted it in. We did f of 4, we substituted it in. Why is f of a any different? What are you going to do with the a? You're going to substitute it in for the x, so what would it equal? Negative 1/4 what? A plus 2. Write that down. Write that down. Oh. See how easy that was? Huh? That's right. F of x, right, when it's x, I got 1/4 x plus 2. F of a would be 1/4 a plus 2. Okay, I'm just taking that a and substituting it for x. All right, how about this one? F of a red brick. What would an F of a red brick equal? Negative 1/4 red brick plus 2. What I'm trying to instill in your head, guys, is that no matter what goes there, all that happens is that value gets replaced right there. Okay? All right. Your homework is right here, page 32, 1 through 26, and page 41, 1 through 12. Red textbook. Okay? I won't see you again until Friday. So if you need extra help,